All right, today we're going to take a look at adding and subtracting rational expressions, and these will be with uncommon denominators. So the first thing we're going to want to do is make sure that everything is factored, which in this case, this problem it is. And then secondly, we want to see what denominators do we have, a list of things. So we can clearly see, like I said, that these are factored. This one has an x minus 3. So that is one requirement that we have. And the other one is the x minus 5. What we want to do is kind of create a checklist of what our common denominator is, because we can do two things here. We can establish our excluded values, which would be the x equal to 3. X is not equal to 3, actually. And then the x minus 5, which gives us the x not equal to 5 as well. So we have our excluded values just like this. Now, we have to make sure that each side gets what it does not have. Well, the left side has the x minus 3, and the right side has the x minus 5. So we need to provide it with what it does not have. So the x minus 3 does not have an x minus 5. So we're going to multiply that so that we'll have a common denominator. And just like yesterday, we're going to multiply times x minus 5 over x minus 5, which is the equivalent of 1. So we won't be making a value change on this. On the right side, we have an x minus 5, and it's lacking an x minus 3. So we will multiply times x minus 3, and we will also multiply the top by the same amount. Now, it's always a good move to put your binomials in parentheses, just like I've done there. Now, for space sake, I'm going to erase this stuff down here, but we need to know that our excluded values are at 3 and 5. So in the numerator, we're going to distribute the 7 to the x and the 7 to the negative 5. 7 times x, of course, is 7x. 7 times 5 is negative 35. Now, we'll put this denominator together at some point, but right now, let's just go ahead and leave our denominator just as it is, which is x minus 5 times x minus 3. On the right side, we end up with distribution of two binomials. This is where we would actually do the FOIL method. We would go 3 times x, which gives us 3x squared. We would have 3 times negative 3, which is negative 9x. We would then move to the 1. 1 times x, of course, is 1x. So I'm not going to write the 1. I'll just leave it like that. And then lastly, I will distribute the 1 to the negative 3. 1 times negative 3 is negative 3. And again, we'll put our denominator just back as it was. X minus 5 times x minus 3. So now that we have a common denominator, we can push everything in the numerator together. Nice big long line right here. We have an addition here, so we don't have to put the right term in parentheses, but we'll combine like terms and write these over here. So we have on the left side a 7x minus 35, and we will be adding 3x squared, and I'm going to go ahead and combine these two, minus 8x minus 3. So once we've got these established, we're once again going to look for common denominators. Well, I see a 7x and a negative 8x. That's a like term. And I also see that the 3x squared does not have a like term. So I'm going to go ahead and carry that down. 3x squared right there. And we have 7x minus 8x, which is negative 1x. Look for any other like terms. Well, negative 35 and negative 3 do make negative 38. And then we will rewrite our denominator this way. Now, for delta math purposes, you can leave this just like that. The x minus 3 can be in front, the x minus 5 could be in back. A lot of different ways that this could be written. And then one other way that I want to talk about, because this is what you would see if you were on your ACT. Rarely is it left in factored form on the top, on the bottom, and non-factored form on the other side. So the other thing we could do is distribute here. We could FOIL these two. Remember, x times x is x squared. We would have then negative 5 and negative 3. When we combine those, that would make a negative 8x. And then negative 5 times negative 3 is positive 15. Likely you're going to see it like this on your ACT, but for your delta math purposes, we can leave this in a factored form because it does not tell us what type. It just says simplify into one fraction. So either answer should work in delta math, but you are going to want to do that one a little bit easier. A little bit easier if we leave it that way. All right, so here's one. We had one similar to this the other day we discussed, and we have a denominator that looks alike, but if we rewrite this thing, we will see that these are clearly not the same thing. This is negative x plus 8. So in this case, we could multiply times negative 1 and fix this, or we could factor out a negative 1. We could even move it to the top. There's a lot of different ways that we can do this. I'm going to, in this case, just factor out a negative 1, because when we get a common denominator, we can add to something or we could take it away, either one. Just whatever we choose to do, make sure that we do it on both sides. So this is how this is going to work. The left side needs no change. We still have a subtraction sign, and this would be, after I factor out a negative 1, it would be negative 1 times x plus 8. So it would look like this. Now, we can move our negative sign into the numerator, which makes a lot of sense on this question, because when I move it to the numerator, we will have 1 over x minus 8 minus negative 1 over x minus 8. Now, I haven't canceled anything, but I also forgot to acknowledge that my x value cannot be positive 8. We cannot make that denominator equal to 0. And that would be true on either side. So anyways, here we go. We have a common denominator. So we can rewrite that common denominator across the bottom. And then the top would be 1 minus negative 1. So it's 1 minus negative 1. And of course, we know that when we have minus a negative, we actually have plus. So this would be 2 over x minus 8. All right, so here's my favorite one of the whole assignment, because this one requires factoring and multiplying. We also have a subtraction here. So the first thing I want to do is go to the left side, right side, and the denominator can clearly factor, and nothing else can. Everything else is just a either a monomial or a binomial, and we can clearly see that they do not factor. So we need the factors of 42 that can become negative 1. Well, if you go through your factors, what you're going to learn is that it's x minus 7 times x plus 6. Let me encourage you to think about using the other terms to maybe help you as we do these. All right, so our common denominator, here's all of our requirements. We require on the left side an x plus 6. By the way, that is an excluded value of negative 6. On the right side, we require an x minus 7, excluded value of positive 7. And then this also requires an x plus 6, only one of those. And since that x plus 1 is already in the list, we will not write it again. this will satisfy both of the things. They both require an x plus 6. Well, they both have one. So we're good on that. So the right side doesn't need any manipulation. The left side is lacking an x minus 7. So what we're going to do is give it what it's lacking, x minus 7. We will multiply numerator and denominator times what it needs. This would be a distribution in the top. 7 times x. We'll put our result over here. 7x. And it would be 7 times negative 7, which is negative 49. All over x minus 7 times x plus 6. Minus x over x minus 7 times x plus 6. Now later on, if we want to write this as a trinomial, don't reinvent the wheel. Remember, we know what this is because we factored it down. It is this term right here, x squared minus x minus 42. So if you do decide to put those back together, make sure that you know that what it is already. It doesn't take a lot of work. All right, let's keep moving on here. So we have a common denominator, so now we can combine the top. When we combine the top, what we end up with is 7x minus 49 minus x. Move this over here. And then this again will be over x minus 7 times x plus 6 we have 7x minus x, which would be 6x. 49 has no like terms, so we put it just like that. And this would be over x minus 7 times x plus 6. This is what Delta Math wants to see, but I want you to keep in mind this is real easy to put back together because we factored this down, so this obviously came from where we started, which was minus x minus 42. These are both completely correct answers. Neither one is more right than the other. We don't have a standard form for these, so we just choose whichever one we want. And your last example kind of threw a curve at you right here because we do have a subtraction, but it looks like we have a leading term that is not a fraction and the other one that is a fraction. Well, in order to add these, we have to have a common denominator. So since this one has a non-existent denominator that we can visually see, so everything always has a denominator, so this has an understood denominator of 1. I'm going to go ahead and state my excluded value from here. X minus 5 has an excluded value of 5. So we have a denominator of 1 and a denominator of x minus 5. So the right side doesn't need anything to have a common denominator. Our list of things we need is just x minus 5. Technically, you could write a 1, but again, times 1 doesn't do anything for anybody. So what we need to do is give this side what it lacks, which is an x minus 5. We're going to give it to the top and to the bottom. Because remember, that's basically multiplying times 1, because any number divided by itself is 1. Save yourself some trouble here and put that term in parentheses. So I'm going to go ahead and rewrite my denominator. My denominator is x minus 5. Let's move over to the right side where we have this nice little binomial times binomial. So we're going to be distributing. X times 5x is 5x squared. X times 7 is 7x, positive 7x. Then we move to our negative 5. Be careful of your negative signs there. So this would be negative 25x. And then lastly, negative 5 times positive 7 is negative 35. I need to extend my line a little bit here. And we are going to subtract by the other side. Now, if this was a binomial, it's very important you remember to put parentheses, but in this case, it really does not matter because it's just a monomial. We'll next look for our common terms. And like I told you, this is like an Algebra 1 final all in itself. We've got distribution. On the last question, we had factoring. We have combining like terms. We just see a lot of things going on in this question. So we actually have 3 like terms on this one. We have 7x and negative 25x, which is negative 18x, and then an additional 2x, which is going to give us negative 20x. The 5x squared has no like terms, so I'm going to just go ahead and carry it down while we're at it. So 5x squared, no like terms. We said the other ones came out to a negative 20x. And the 35 also has no like terms. So it becomes here. We pull this over and we have our common denominator of x minus 5. And this is our answer. I want to talk about something as well, but that's your answer. That's what you'll want to put into Delta Math. So I'm looking at this answer and I realize, hey, 5, 20, and 35 all have factors of 5. So I factor out of 5 and let's see what comes of it. So I factor out of 5 and it leaves me with x squared minus 4x minus 7 over x minus 5. And that 5 cannot cancel with anything. We could leave it factored as it is, or we could just put it back the way it belongs, the way it was. Sometimes that'll happen. You'll see something and you'll think that that's going to get you somewhere. But in this case, that factoring out of 5 does not get me anywhere. Doesn't make it wrong. This answer is also 100% accurate. It actually is a better looking answer than the first one, but they are both equally correct with an excluded value of positive 5. All right. Again, we'll keep getting more and more difficult on these. We'll have more factoring. Like I said, my favorite question was the third one, where we had to factor before finding a common denominator. It won't be long before we're factoring both sides to get the common denominator. And that's where we get a little bit trickier, and you got to make sure you take your time, make sure you're factoring appropriately. All right, good luck.